Starting. Alrighty. Hello, everyone. Welcome to this Ethereum 101. Okay. I cannot have. Hello, everyone. Welcome to this Ethereum 101. Okay. Zoe, could you turn off the volume on your live stream? You don't have to mute yourself in the Hangout, but if you could just, like on your local computer, like on YouTube, just mute the volume there and it should be fine.
Okay, sorry.
All good.
Unmute, okay.
Sweet. Hello, everyone. I'm Elliot. I'm the Director of Blockchain Program here at the Den. Today, we're going to be talking about Ethereum 101.
Perfect. Yeah?
Yeah.
Hi, guys. I'm Zoe, Community Manager from the Den, and I will be moderating the chat today and happy to answer some questions from you. Or actually guide them to Elliot, but feel free to raise questions.
Here we go. The voice through which the community speaks. There we go. Alrighty. I guess let's get right into it here. Let me share my screen. Okay. All right, I guess we already got the intro here. We're introducing Ethereum, and the Den, we're the decentralized education nexus. So essentially what we do is we help business professionals, entrepreneurs, and developers get a very strong understanding of blockchain so they can leverage it to go and kick off a career in this new and exciting space. And we're going to be giving out a discount code at the end. So if you stay to the end of the webinar, we'll give you a discount off of all of our classes. And so without further ado, let's get into the introduction to Ethereum. So let's see what Ethereum is all about. Okay, so what we're going to kind of do is we're just going to go from a high level. We're going to go from how we went from Bitcoin to Ethereum. We're going to talk about how Ethereum works, what's kind of different about Ethereum. We're not going to get too technical, though. We don't want to bore anyone, or we don't want to bore anyone with the technical details right now. And then after we get into kind of how Ethereum works, we're going to say, okay, well, we understand this from a very high level. What are kind of the things that we can use this for to solve problems? So we're going to go over use cases as well. So without further ado, let's get into it. So this is just kind of a question we have here. This is a very open question. So which came first, Bitcoin or blockchain? And I want you guys to just go ahead and type this in the chat. Just let me know which one you think came first, because this is it's a very interesting conundrum here. And we'll wait. We'll give everyone a minute to reply to this. So we'll just give everyone a minute, and Zoe will let us know what everyone's saying in the chat. Okay.
Interesting. Blockchain came up already.
Okay, blockchain.
Mm-hmm.
Okay. One for blockchain.
Yeah.
Chris, what do you think of
one for Bitcoin and another one for blockchain. Interesting.
Okay. Two for blockchain, one for Bitcoin.
Yes.
Okay. Chris, what do you think? Or actually, Zoe, let's get the community manager's opinion here.
Yes. Chris?
Yeah, he might not be in the chat. Let's hear from you, Zoe. Which one do you think came first?
I'm also for blockchain.
Blockchain.
Yeah.
Alrighty. Well, I'd say we got enough audience response at this point.
Yeah.
And essentially, there really isn't an answer of one or the other that came first, because essentially without without Satoshi wanting to create Bitcoin, there wouldn't have been blockchain. But then at the same time, you couldn't have made Bitcoin without a blockchain. So it's kind of like a chicken and egg problem. Which came first? Essentially, you need both. You need one to have the other. So, it's not really possible to say which one came first, though you would have had to develop a blockchain before you could have created Bitcoin. So blockchain would have been like the more correct answer. Okay, so this is just a look at a blockchain right here. So we have something in blockchains called a consensus mechanism, and that is the mechanism by which we all agree that new data that we add to this chain is valid. So in this chain of blocks right here, we have 4 blocks from blocks 51 to 54, and we say the consensus mechanism that we use to agree that a new block is valid is proof of work. And so what that means is, essentially, in order to validate a new block or to create a new block, what you have to do is take, this data from the block called the block header, and you have to hash it. And when you hash it, you add on this special value called a nonce value. And the property of this is when you add the nonce value on to this this piece of data and you hash that piece of data, you're going to get an output.
Can you explain more about hashing process, or what this exactly means?
Yeah, so hashing is a deterministic one-way function where you put some input in and you get a fixed size output. So let's say you put in the word the den, or the 2 words the den. Okay, you put those 7 characters into this hashing algorithm and you get 32 bytes out. You put in the word phone and you get some other unique output of the same length. So the hashing output for any size input will always produce the same size output. And a property of a hashing function is for any input you give, the output is always the same. So if you put in the den to the hashing function, the output is some 32 character string. Now if you change anything about how you spell the den, let's say you capitalize a letter, now it's going to completely change the output. But let's say if I go and compute the hash of the den on my computer and Zoe computes the hash of the den on her computer, then we'll both be able to understand, okay, the den equals this fixed length output. So essentially it allows us to take a lot of data and turn it into a small amount of data. And one of the properties of hashing functions is it's hard to get these leading zeros on hashes. It's just rare. It's just kind of a property of hashes. And so what we do with proof of work is we play off this property because we understand that it's hard to get 10 leading zeros when you hash something. So what we do is we say, okay, here's what you have to do. You go and hash this data 1,000,000 times, but every time you hash it, you add a new bit of data onto it. And when you add that new bit of data onto it, it's going to give you a completely different hash. So in proof of work, you're really just guessing these random values that you add onto this block header, and then you hash it. And then if you have enough leading zeros on your hash output, now you have something that's called a valid proof of work, and you get to create the block, and you get the block reward.
Okay, we have another question up. Is hashing similar to encryption from Guru?
No, so the hashing is not encryption. It's not really similar to encryption, but it's kind of in the same area, kind of in security. Because with a hash, you can determine if data has been tampered with. So let's say, for example, I send some data to Zoe. I send her a message, and before I send the message, I get the hash of the message. So this is, let's say 20 characters, 20 character string. Now I send her the data, and I say, hey, Zoe, send me your hash. And then she says, okay, let me send you the hash. She takes the data that I sent her, she hashes it, and then she sends me the hash. And then I can compare with, let's say the original hash before I sent it to her to the hash she sent me. So if someone was listening in the middle to our communication and changed the message that I sent to her, when she sends that hashed data back, I'll be able to know, oh, wait a second, something went wrong here because the hash outputs aren't the same, and they should be the same if she was in fact given the exact same piece of data.
Great. Hope this answers the question, Guru. If not, feel free to raise more questions.
Yeah. Yeah. So with these proofs of work in the block header, we link each previous block. We say, okay, hey, we know what our current block is, but let's also include the hash from the previous block. So that gets hashed in. Meaning if you're at block 53 and you want to go back and modify block 52, then you'd also have to go, like let's say you're at block 53, you have to modify block 52 if you want to go change what happened in the past, which requires a lot of computational power. So essentially, proof of work keeps a chain secure from people coming in and attacking or rewriting a chain, because once you rewrite, a block, then you're going to need a completely different proof of work value, and that's going to mess up everything that comes after it, which means you have to have a lot of computational resources in order to go back in time, change stuff, and then be able to kind of bring it up to the current block. And I think that's about as much as I'm going to go into this right now. But if you still have questions about how proof of work works, let me know at the end and I can answer your question individually. And also in our developer course, we really go into proof of work and kind of all of the details that make proof of work happen. So let's move on here. So essentially, we started off with Bitcoin, and Bitcoin was the first blockchain. And so people, this is just like a really new thing, and people were like, wow, this is so cool. I can transfer money to people without anyone's permission. But then people kind of realized, wait a second, Bitcoin is a blockchain that's used for currency, but we realized that this distributed ledger technology has all these interesting properties such as immutability, and it can be used in so many other applications. So that's kind of what we're seeing right now is that, okay, wow, there's a lot of stuff that we can actually do with this technology, not just use it for currency. Okay, so now we're going to kind of transition into how Ethereum was born. So we've kind of talked a little bit about the mechanisms underlying Bitcoin. Let's go into Ethereum. So Ethereum was essentially born out of this need to be able to build things on top of Bitcoin. And that might not make a lot of sense, but I'm going to explain. So with Bitcoin, there are these protocols that were developed, Omni, Counterparty, a bunch of these protocols that essentially let you piggyback off of Bitcoin. And so what this meant was you could essentially go and create your own asset on top of Bitcoin. And to most people, you're like, well, why do I need to create an asset on top of Bitcoin? Well, the reason you would want to create an asset here is because, let's say I own a gold mine and I produce, a bar of gold a day, let's say. And I have all these bars of gold, but I just don't have anyone to sell them to. And so I said, well, wait a second, I could sell it to, these people who are making jewelry, but they're going to kind of underpay me. I could sell it to a bank, but they're going to pay me less because they need to take a profit. And I get this idea, well, wait a second, what if I become a gold bank and I can just issue tokens online that represent bars of gold in my vault? Well, kind of previously, before blockchain, that's a really hard thing to do. You would have to set up, these huge you'd have to set up a ton of legal paperwork, and you'd have to go through a lot of legal processes. and it would take you a ton of money in lawyer fees, and it just was like a really big headache to deal with this. But when Bitcoin came along, people realized, well, I can use Bitcoin for more than just Bitcoin. I can use Bitcoin to represent an asset in the real world by piggybacking off the protocol. So how this was done was people saw that there's this this opcode in Bitcoin that was the op return. And the op return allowed you to send a transaction that could never be redeemed. And so it's essentially a garbage transaction. And what you do is you just attach some data to this op return. And these protocols like Counterparty and Omni that were building, asset solutions on top of the chain, they would go they would comb through the blockchain, pick up all the data in these op returns, and go and use that to essentially have a state on this layer 2 application. And so then you could see, okay, wait a second, Elliot sent something to Chris, Elliot sent something to Zoe, Zoe sent something to Chris. You could see where people were moving these assets that weren't just Bitcoin, but they were something more. So these transactions represented more value and more items. And kind of what happened with these colored coins was in 2013, the Bitcoin core team said, you know what? We see all these people building out these colored coins. We really don't like it because this is, people are bringing in these other assets, and Bitcoin is for Bitcoin. It's not really for, people to go and build altcoins or, tokens on top of. So essentially, what happened was the op return, which was where all this data for these token transactions were stored, it was restricted from 80 bytes to 40 bytes. And essentially a month after this happened, I believe the Counterparty team sent a plea in to the Bitcoin core team. They said, guys, please change the op return from 40 to 80 bytes so that we can have our protocol working again. And it took the Bitcoin core team a year to get around to it, which, is kind of needless because it's a very small tweak. You just change probably like a few lines of code, from 40 to 80. And now people can go and do these things again. But the Bitcoin core team wasn't really, they weren't too rushed to figure this out or to go back and change this code. So it took them a year to get around to it, and they finally got around to it. And at the time, Vitalik was a Bitcoin core contributor. So he was contributing to Bitcoin. He was kind of looking at all these like colored coins. He was looking at, Omni, and he was like, man, this is really interesting. And he went to these guys who had all these protocols, and he said, okay, look, with your current protocol, you could develop all these things on top of Bitcoin, but you can't develop really programs. So what if we could put programs onto the blockchain? And everyone looked at him and they're like, man, this is crazy. It's just like a lot of work, like who really needs this? And so Vitalik was just kind of feeling that he was kind of alienated from the community. No one really wanted to see these colored coins succeed, and no one really wanted to go overhaul the protocols on the colored coins to make them have more functionality. So Vitalik said, okay, I'm going to go start my own thing. And so that's kind of colored coins and how it kind of ties into Ethereum. So Vitalik said, hey, there's all these things that can be built on top of Bitcoin, but the Bitcoin core team isn't interested in modifying the protocol. These other guys that have like layer 2 protocols or layer 2 solutions, they're not interested in changing their things. So I'm going to make my own blockchain from scratch and kind of build this world computer. That was Vitalik's vision. He wanted to build a computer that's decentralized, that anyone can participate in. So let's go on from that. Mm-hmm. So it's also very inefficient to store data on the Bitcoin blockchain. It's costly. It doesn't really scale. It's an all around bad solution for any sort of data storage. Op return script is not recommended by the core team. So that opcode that you kind of need in order to build these layer 2 solutions, the core team was like, yeah, we really don't want you to use this, and you probably shouldn't. So it's kind of discouraged to use that, the op return. Very expensive to store data on Bitcoin. And let's say you want to fork Bitcoin, use it as a separate currency. It's a lot of work, right? So like, let's say I want to make, let's go back to the gold bar example from before. I want to, make these gold bar tokens and let people buy gold bars that I have in my vault. Well, the problem with that is if I don't build it on top of Bitcoin and I don't have any other options, my only option is to go to fork Bitcoin and use that to represent my currency, which is a complete pain. Now I have to deal with kind of securing the network. So it doesn't really make a lot of sense if you want to just make your own currency for whatever reason to fork Bitcoin. Also, Bitcoin is very limited on transaction throughput on layer 1. So unless you're using layer 2, which is kind of hard with these layer 2 protocols where you're dealing with assets, it's really hard to make something that scales when, let's say 1,000 people are trying to access a program in 1 second. So Ethereum was kind of designed with Bitcoin's shortcomings in mind. So they said, okay, well, Bitcoin was made one way, but let's make Ethereum in a way that's structured better and can actually handle increased transaction throughput. Yeah, and essentially Vitalik, the Bitcoin core team just said, hey, we're not interested in really changing anything about Bitcoin. We're not interested in these colored coins, and we're not really interested in making Bitcoin a world computer. So Vitalik said, okay, I'll go make it myself then. So this is just actually before we go on, do we have any questions? I don't want to have anyone get lost here.
No open questions right now, but if someone has questions, please raise them.
Got it. Okay. So this is just Bitcoin versus Ethereum right here. So with Bitcoin, we have these blocks, and in the blocks we include transactions. And so these transactions in Bitcoin allow us to move money from one person to another. And there's only really one type of account on Bitcoin, meaning, yes, there's only one type of account. And I'll get into that later and what that means. Then we have Ethereum. And Ethereum, we have blocks and we have transactions in the blocks. But with Ethereum, we have smart contracts. And so what that means is that you can send your Ethereum from your personal wallet to an automated account. And that automated account will do something based on the Ethereum you send it. So essentially this opens up like a whole new world for developers and people who actually want to build stuff on top of this chain. Whereas for Bitcoin, you couldn't program something with the current Bitcoin opcodes, that has a concept of state that says, hey, after 1,000 people spend money from this, UTXO, this UTXO is expiring or will not send any more money out. You can't really have a very good logical conditional flows in Bitcoin. I mean, there's like some if statements in the opcodes, but compared to Ethereum, where there's like Turing completeness and you can do jumps and you can call other functions, Bitcoin doesn't really compare to Ethereum in terms of what you can build on top of it. Okay, so let's talk about how these chains work. So you should think of a blockchain it's an append-only ledger, meaning you can only add on data. You can never go back and change previous data inside the chain. So think about adding data, or let's say think about a blockchain as if it's a Word document, and every time you hit save, you're adding a new block. So you have a Word document, you type some words out, you hit Command Save. Now that data is stored on your disk or stored on your computer somewhere. And so essentially that's the same thing that we have with blockchain, except every new block is a Command Save, because what you're doing is you're adding new data to this chain, so you're storing new stuff. You're saving a new state. So essentially, when you send a transaction is actually what changes the state, because it sends money from one person to another, or in Ethereum's case, it could actually change the state of an application. And so essentially, for every block, there's all these different state changes, and Ethereum, will go through every single state change one by one, and everyone will update their local version of what this world computer looks like. So you could think of it like, everyone has a laptop. We're all running Windows 10, let's say, and we're playing a video game. And anytime one person, makes a change to where they are on the position of the map, that change is sent to everyone else. And we store that data so we can go back and see how the game progressed from beginning to end. Okay, so this is just a little bit of a comparison here. Bitcoin, that was released in 2009, that date's wrong. Ethereum was released 2015. The founder of Bitcoin was anonymous. We don't know who he was. And Ethereum was created by Vitalik Buterin. With Bitcoin, it was Genesis block mined from day one. So there was no kind of like pre-sale for Bitcoin, though you could make a case that it was kind of insta-mined, if you will, because there really wasn't any competition at the time, and no one really knew about this. But it wasn't an intentional thing, so it wasn't, it wasn't a developer kind of just trying to be greedy. And Ethereum, right? They had this pre-sale. I think they raised like 15 to 20 million. And Bitcoin, uses proof of work. Ethereum uses proof of work, but they're planning for proof of stake and sharding. And that's going to be, I recently attended a talk about how they're going to shard the different chains. And it's really crazy, because at this point, Ethereum isn't really even sure about how this sharding is going to work and how all these different shards will be able to communicate with each other. So very interesting stuff. Let's see here. So for the proof of work algorithm, Bitcoin uses SHA-256, which is a secure hashing algorithm, and it outputs 256 bits from the hashing function. And Ethereum uses ETH hash. So ETH hash is this this mining algorithm with this DAG. So you have this huge graph on your GPU. You load it up into your GPU, and then what you do is you have to go and traverse. You have to go kind of slice through this DAG at random points and see if when you slice at this point and at this point, and you go through this data, it gives you this certain hash output. So it's very, very memory intensive. And some people who had 4 GB or like 2 GB graphic cards had to upgrade because the size of the DAG just increased. So they had to get 4 GB graphic cards. The block time on Bitcoin is 10 minutes. On Ethereum is 12 to 14 seconds. So Ethereum is much faster for transactions because it's meant to be a world computer, and you really wouldn't want a program that you're interacting with to take 10 minutes to respond. That's just very inconvenient. Like imagine going to Facebook and taking 10 minutes to go and post a new photo or new status. It just wouldn't make sense. So Ethereum said, okay, let's just change the block time so that when people build applications, things update relatively quickly. And Bitcoin, it's not super scalable from a block size perspective. However, there's a ton of layer 2 solutions being worked on, like Lightning Network. And so Lightning Network, it lets people have payment channels. So there's scalability, but it wasn't exactly built into the core protocol. With Ethereum, scalability was built in by default. So what they did was they said there's a block or there's a gas limit, which means we can process a certain amount of computations per block. But what's great about Ethereum is that miners can actually vote to increase the block gas limit. So they can say, hey, look, we've had, our blocks completely full for the past, 2 hours. And because of this, let's vote to increase the block size so that we can handle all these transactions and get the network, kind of back to a stable state. So Ethereum was essentially designed from the beginning to be a very, very scalable solution. Okay, so Ethereum has these units of denomination. So they have one way. One way is the smallest unit of Ethereum you can actually own. And if you only own one way, you probably can't send anything because the gas fees for a transaction are much, much, much more than just one way. Then we have a kiloway, a megaway. Megaway is a million way. A gigaway is a billion way. We have a SOSBO, which is a trillion way. And SOSBO, so we have a SOSBO and we have a Finny. And a Finny is 1,000 trillion way. And SOSBO is this unit of Ethereum. It was named after Nick Szabo. He's like a famous cryptographer and computer scientist, and he was very, very involved with Bitcoin in the early days. So Vitalik wanted to kind of pay his respects and said, okay, hey, the guys who really worked to create this technology, let's pay our respects to them. So Szabo, really well-known guy in the Bitcoin community, and Hal Finney, who was actually in direct contact with Satoshi Nakamoto. They're both mentioned here because they were very integral in the early days of kind of building Bitcoin and providing direction for the project. And then we have an Ether, which is 10 to the 18 way. So it's just an Ether is like a million trillion way. So these are just kind of the units of denomination. Okay, so Ethereum is essentially just a state machine. And so every single block updates the Ethereum state. So let's say we're working, let's just say we're on our own new version of Ethereum right now. The state is I have 10 Ether and Zoe has 12 Ether. And now if Zoe sends me, she sends a transaction from her account to my account, she sends me 2 Ether. Now we'll make this transaction, when it gets included in a block, we'll update the state. And so now we'll go from, Zoe having 12 and me having 10 to me having 12 and her having 10. And that's kind of how the state can change in Ethereum. And everyone agrees when they process these transactions on what the new state of the network is. So everyone reaches consensus because everyone processes all transactions. And yeah, you can't make a change to the state of the network without sending a transaction. So a transaction is the only way to transition state. Okay, so now let's go into accounts more. So in Ethereum, we have 2 different types of accounts. We have an externally owned account, and that's an address that's derived from a public key and controlled with a private key. And an EOA or an externally owned account is something that's created with, it's created by a human being, or we'll just say it's created by a human being. And then we have contract accounts, and those are derived from the creator's address and the nonce, meaning the amount of transactions the creator has sent, and it's controlled by code. And so what this means is once you make a contract account, it essentially is, how can I describe this? The contract is essentially self-governing. So once you deploy a contract, people are allowed to interact with the contract. And there's like predefined rules for what will happen when people interact with the contract in certain ways. So in Solidity, you build out functions, and people are allowed to call functions and they can use that to update the state of a contract. And we'll kind of get more into this and what this means later on. And you can send a transaction that contains ether and or code. So you could send a transaction, like we said earlier, just from Zoe to me or from me to Zoe. And we can also send a transaction to deploy a contract. So that that transaction will contain code. So let's say if we want to create a contract, we send a transaction to address 0, and we send compiled bytecode to the EVM, which executes and then outputs the code to the blockchain in the form of a contract. Yeah. So now we understand we have this kind of distributed ledger, and we have an operating system that works very, very closely with this ledger. So in Ethereum, we have something called gas cost. So essentially, gas is the unit. It's essentially how you pay for all these transactions to execute. So let's say you're talking to a contract, and the contract has to do 20,000 computations. You have to pay a gas, or you have to pay a unit of you have to pay per computation. We'll get more into this right here. So there's a gas cost, and this is set by the creator of the contract. So let me think about this for a second. So the longer your functions are, the more complex your contract is, and the more computational steps, the higher the gas cost, because it's going to take someone, because there's more computational steps. And so the gas cost depends on the number of computational steps. And just kind of an example here, let's say you have a contract that's supposed to, or you have a function in your contract that's supposed to add 2 numbers, and you have a function that's supposed to multiply 2 numbers. Okay. Well, if you multiply 2 and 2 and you add 2 and 2, you get the same result 4. And let's say, well, when you look at the opcodes, every single type of computation costs a different amount of gas. So let's say a multiplication opcode is going to be, 1 gas or 3 gas, but addition, that opcode takes 1 gas. So even though you're getting the same result, which is 4, the way that you got there is going to kind of determine how much it's going to take to get there. So essentially, when you design these contracts, you want to make them as kind of short and succinct as possible, because when you add functions that are hundreds of lines of code, or you wouldn't want a function that's 100 lines of code in the first place, but let's say you have a function that's 25 lines and it has a few loops in it. Well, now it's going to take you a lot of gas to execute that one function. So when you're programming smart contracts, you have to really be considerate of the environment that you're programming on top of. Okay, so then we have the gas price, and this is how much gas you're willing to pay for each unit of gas needed. So let's say I call the contract that just adds 2 numbers. I tell the Ethereum network, when I create this transaction, I say, I'm willing to pay 1,000 Wei per unit of computation. And that essentially means when I do, this one little operation, I'll have to pay 1,000 gas because I did 1 unit of computation. If I did 2 units of computation, it would be 2,000 gas, kind of so on and so forth. So every operation has a cost, and you have to specify in gas. So it says this is the amount of steps there are, or this is how much gas something costs, and you have to specify how much you're willing to pay for each step. Then there's also the gas limit, and this is the maximum amount of gas you're willing to spend. So you say, okay, well, I'm only willing to spend 20 gas to go execute this contract function. But let's say that the contract function needs 50 gas to execute, and you only say 20 gas. Well, what happens then is the call will revert meaning there will be no changes made to the state and there will be no return to value. So you have to make sure when you're interacting with the contract that you give it enough gas so that it can actually fully execute the function. And it's kind of best practice whenever you're talking to a contract to send more gas than you need, because any extra gas that you give is refunded. And of course, not enough gas will stop the contract in the middle of its execution, and you won't be refunded any gas. And essentially, this is needed. Gas is needed because if people don't have to pay any money for computing power, or they don't have to pay anything to be part of this network or to kind of change state, what will happen is people will just change state infinitely. So you could have a contract that just has an infinite loop, and it just goes and writes to storage. And then everyone who is running an Ethereum node would have to process this infinite loop, and if they're not getting paid for it, why should they bog down their CPU with this kind of fruitless operation? So there's this concept of gas, because we realize that if things are free, there will be bad actors who are just able to come in and just kind of destroy the network for everyone. So gas is really a good thing, even though you wouldn't really think of spending $1 to post a photo on Facebook. Ethereum needs this, because if you don't have this, people will bog down the network. All right, so let's talk about reading and writing to the blockchain. So essentially, on a blockchain, reading is free. So it's free to take any information that's inside the blockchain currently and kind of look at it. And writing costs you money. So let's say I would want to talk to a smart contract and have it change its internal state. That's going to cost me money. But just reading from the smart contract and seeing all the variable values and whatever, that's completely free. But storing data is very expensive on chain, because everyone has to keep a copy of that data. And currently, the Ethereum is kind of modeled around you just pay once and it's like done forever, right? So you can pay once and store something forever on chain. But they're kind of moving away from that model, and in future releases of Ethereum, they think that, or the Ethereum team kind of wants to move more towards a rental model. And so that means that you essentially will pay for a certain amount of time to store your data on chain. And so that would essentially kind of help prevent blockchain bloat. So, if there's an application that has data that's 10 years old and no one's using that application anymore, it's kind of been abandoned, why should everyone store that data? So then, that data will be deleted automatically unless the owners pay to have that data still stored. There's other kind of ways that we can store data. We can emit events, and that's kind of more on the smart contract side. So there's other ways that we can kind of use the blockchain and not just store a ton of data there, which is very expensive. And I just want to let if anyone has questions right now as we're going, feel free to shout them out in the chat. Yeah, and anything unclear so far, Zoe?
Sorry, no, I posted it. No questions coming up, so I will let you know. Great.
All right. Yeah, so reading is free, right? You can pull data out of the chain for free. Okay, so now let's go into the Ethereum ecosystem. So we have something called Swarm, and Swarm is essentially a decentralized and distributed file storage system. And Swarm is going to be kind of used to store media and just kind of data, and it'll be very closely linked with the Ethereum blockchain, because it's developed by people who are kind of funded by Ethereum. But I'm not 100% sure on what the use case is, because to me it would make sense if the EVM was modified and contracts could reference storage external to the chain, but that's not kind of how they want to implement it. So Swarm, it's a distributed file storage place, and maybe it's kind of used for people who have smart contracts or dApps, and they don't want to host, let's say, the web page on AWS services. You could host that on Swarm, and you'll also be able to pay for peers, hard drive space with Ethereum. There's also a lot of competitors in this space. So there's storage, there's SiaCoin, there's Filecoin. There's also IPFS, which is currently working. So there's a lot of kind of different decentralized file storage solutions, but Swarm aims to be decentralized file storage for the Ethereum ecosystem. All right, DDoS resistant, zero downtime, fault tolerant, censorship resistant, kind of everything that you would want out of a distributed service. And essentially, nodes are incentivized, so people will say, hey, I'm willing to pay $1 a gigabyte. That's probably way too high, but people are essentially able to just go and pay for space on people who are hosting data on this network. So as an end user, I could say, oh, I want this really funny video I made. I want it hosted on Swarm, and I'm willing to pay X Ether per year for you to store this video here. And then it gets kind of distributed among peers and stored so that it can't get taken down. So then we have this protocol called Whisper, and Whisper is this protocol that allows you to essentially send messages on top of the blockchain, but it doesn't ever actually interface with the blockchain, and the data of the messages doesn't get stored in the blockchain. So it's kind of confusing, doesn't make a lot of sense, but let me explain. So as a user, you can say, okay, I'm going to send a message from my phone to a friend's phone. And instead of routing this information, through like a centralized server, maybe like AWS or Google Cloud, essentially what happens is this data gets routed through peers on the blockchain that have enabled this. So I say, hey, I want to send this message to person X. And I broadcast this message out to certain nodes on the Ethereum blockchain. And those nodes, they see my message, and they go and find that person, and they go send that encrypted message over to that person, and that person decrypts it, and then they can read it, and they're like, oh, okay, well, Elliot wants to go play this game. And so the use case for this would be, let's say you want to talk to someone on Swarm. Before you buy their storage, you talk to them and say, hey, let's negotiate this price. Or you could use this for a smart contract. You could talk to the owner of a smart contract and say, hey, what does your contract do? How can I interface with it? And then they'll kind of give you instructions for using it. And also the data is never stored, which is great. So there's no like logs that you sent that message. It just gets routed through a peer. The peer gets to see the, essentially pass the encrypted packet through to whoever you're routing it to. And so this will kind of be something that will hopefully be kind of widely adopted. But it also, I think, once there are like applications where you can just put it on your phone, you can put Whisper on your phone, people may use this as an alternative to Signal or as an alternative to encrypted messaging platforms. So this is kind of very interesting technology, but I'm not 100% sure how it will really integrate and how it will really be adopted by the community. Yeah, so the protocol is separate from blockchain. Smart contracts don't have access to data that's sent in this manner. Okay, so this is kind of the overall architecture of Ethereum. So we have smart contracts here, and then we have the swarm, and we figure that there will be some sort of overlap between contracts and swarm, where let's say the smart contracts, they have these events, and the swarm has hosts the files to interact with these events. So the swarm could be like your distributed server, and you just go upload some files to a swarm, and people can go to the swarm address on their computer, and they can see these files, and that lets them interface with the smart contract. Then we also have Whisper, so you might use Whisper before you interact with someone over a contract, or you might use Whisper before you interact with someone on the swarm to kind of negotiate the price for the data. And there's obviously like a lot more things that you can do with this technology, but these are just kind of use cases that I've kind of thought of and just pieced together from the information that I've seen from the community. Okay, so let's get into use cases now. So we've talked about kind of smart contracts. We haven't really gone too much into detail about what they can do. Now let's kind of go into things that we can use these applications for, and we'll kind of break down why these cases make sense. Okay, so first, if we can record deeds and transfer property through the blockchain, that's a really, really great use of a smart contract and a blockchain, because you have data that you don't want to ever be able to, you don't want this data to ever be tampered with, right? You wouldn't want someone to be able to just go and say tomorrow, oh, I'm going to steal your deed. I'm just going to go, hack this, or just, take your deed away from you. So with the blockchain, everything is transparent. And if the smart contracts are coded correctly, you won't be able to take something from someone that you're not really allowed to take. And this could be really great in third world countries where there's a lot of corruption, because let's say you have these smart contracts, it makes it a lot harder for, let's say, an official to take a bribe, because now everyone would either see the bribe, let's say it was given on chain, or let's say you put in a request to transfer the deed, and it takes the officials 30 days when they're mandated to do it in 5 days. You can see that there's foul play there. So it can keep people accountable if used properly. You can use this for digital identity and digital rights. So you could store a proof that you own some data on the blockchain. You could just take a hash of some data you have and store it on the blockchain, and that would prove that you owned something without actually proving what it is you own, unless, let's say, you had to go to court because someone stole your song. You could go prove, hey, look, I stored the hash of this song on the blockchain 5 years ago, and yet 2 years ago this person claimed to have created the same song that I made. So then you could kind of go say, oh, hey, look, this thing actually belonged to me. And you could also kind of use this for digital identity. So you could store your identity on the chain, and you wouldn't necessarily include all the details about yourself, but you would be, let's say, verified by a trusted third party that says, hey, this person, hey, Elliot, meets these requirements. So he is a U.S. citizen, he's a registered voter, and then I could go to different places, and I wouldn't have to present all my identification. I just say, okay, this person is certified by the U.S. government that he has all these things, and so therefore, there's no problems here. Another use case is kind of tracking goods. So Hyperledger is currently being used to track diamonds, and so they just say, okay, hey, when a diamond is mined, we put it on the blockchain, and we track it from wherever it's mined to wherever it's eventually sold and that way the consumer can know, hey, I didn't get a blood diamond. But of course, this only really works if the people who are registering the diamonds are being truthful. Because let's say you're in South Africa and there's all these diamonds that you're mining, but then you have a friend in Sierra Leone who comes to you and says, hey, look, I got 1,000 diamonds, but I can't unload them because they're blood diamonds. And then you start putting those blood diamonds on the chain and saying they were from South Africa. Unless there's a really, really strict procedure for putting these diamonds on the chain, well, then a lot of these things can kind of be fudged, or you can kind of get around the things that the blockchain actually used. So what we see a lot is the blockchain is really only as trustworthy as the people that run it, except in very, very certain edge cases. So there's also, right, blockchain is really great for loyalty points. So Burger King, they announced that they're rolling out this program where you can go and, like, every time you go to Burger King, you get a burger and fries, they'll give you so many loyalty points. But those loyalty points aren't just like on an app, they're actually on a blockchain, which means you can kind of transfer these loyalty points wherever you want. And it could kind of give the customer a better sense of what these loyalty points are worth, because they could see, oh, someone's willing to buy my loyalty points for 1 cent a piece. And so then you can kind of, see as the end user what loyalty points are actually worth. We also have a supply chain. So let's say, you're Apple and you call it Foxconn. You say, I want 100,000 new iPhone 9s or whatever it is. Now, instead of putting in this order through paper to Foxconn, where Foxconn will take your order, they'll have to go call back Apple and say, hey, is this order legitimate? It takes like a few days. If you have a trusted network where you trust that everyone on this network is who they say they are, so you vet them once, but then you trust them forever, then you just say, okay, well, Apple joined the supply chain, Foxconn joined this supply chain blockchain application, and now these two people can talk to each other, and Apple can submit a work order and say, hey, look, I need 100,000 iPhone 10s. And Foxconn says, okay, great, send over the plans. And they don't have to spend time, worrying, oh, is this work order legitimate? They just know, okay, hey, this is real. Let's get on this work order immediately. Let's not waste any time figuring out whether or not it's real, because we actually trust where this data came from. Okay, so another kind of use case for these decentralized applications are Dows. So Dows are decentralized autonomous organizations. And what you can do with a DAO is you can essentially set up companies that are decentralized. So instead of having one kind of central hierarchical kind of order, you can just say, okay, everyone has an equal share in this voting, and everyone can kind of make decisions about how we govern this company and how we move forward. And now, obviously, this is, this introduces a lot of problems, and this was something in 2018. I remember Vitalik saying that DAOs were kind of overplayed, meaning that people kind of overestimate the use case for a DAO, because there's already kind of frameworks like this, where you have like an employee-owned company. That's essentially the same thing as a DAO, where the employees own a part of the company. So the DAO is an interesting thing, but I don't know if we're going to see a lot of DAOs in the future. And let's kind of brainstorm here about some other use cases, right? We mentioned the DAO, we mentioned tracking, we mentioned loyalty points. What other things can we use blockchain for? Let's get some people from the comments share out and see what they have to say.
Mm-hmm. Some other use cases, you heard about, or you maybe think could be a good real world use case.
Say that again?
Yeah, just repeat that that they can share more real world use cases they heard about, maybe, or
Yep.
applicable. Energy, for example, energy transaction or energy consumption. Elliot, also a use case? Tracking of energy consumption, maybe?
Yeah, that could be interesting. So you could have like an IoT device on your house at any time, every minute it'll send some data back to the power company about your power usage, and they'll just store that data on a chain, blockchain. That could be a good use. And then that's kind of, it's really hard to fudge the data on that unless you actually go and tamper with the electronic itself on your house. Yeah, that's
again, in general, blockchain IoT is also the combination is a great use case. But as you said before, like you can only trust what you put in, right? So you have to trust IoT device too.
Yes, exactly. Yeah, because the people can just go, make hard code their or go change the firmware in their electricity thing to just say, oh, we use 0 amount of power. Then all of a sudden your system doesn't really work and people are just getting all this free power. So the blockchain is only as good for storing data as the data that's put into it.
Right. Yeah.
Another thing for a DAO, maybe this is kind of a scary vision for the future. The technology isn't there right now, but it could be in the future. Let's say someone launches an AI DAO that says, my only mission is profit. Then, and then the DAO starts, paying people to do bad things in the real world, and it starts taking bets, so it says, okay, hey, shut off the power. The DAO pays a hacker, this AI DAO pays a hacker to shut off the power in the city, and then the DAO shorts some stock that it know will go down if the city's power is down because the company can't operate. So that would be like a very bleak vision for the future. If these DAOs could just start like manipulating the world around themselves and just like acting for profit. But luckily, that really isn't there right now because the EVM is too slow and expensive to run any real algorithms on top of it. So that's not going to be happening anytime soon, which is good.
Okay, some other use cases from the community didn't come up something, but if you have something, feel free.
All right. Well, we'll go over some other use cases we have. We can use blockchain for just a ton of different things. For security, we can use it for kind of KYC, so know your customer, and anti-money laundering. So we could just say, hey, we store your digital identity on chain, but it doesn't contain any identifying information. So all it says is user 22150 is, all it just says is, hey, this person is approved for this, this, and this. And it doesn't say anything else. That would be a really great use case because then you're not exposing anything to the world that you wouldn't want the world to know. And then kind of everyone can see like, oh, okay, this person, even though we don't know who they are, we don't know their name, we understand that they're certified in X, Y, and Z, or they're allowed to participate in this system. Risk management and auditing. I think auditing is going to be a really, really big use case because whenever we have IBM buy, they always talk about auditing. Because if you're a corporation, you have all this kind of expense where you have to spend all this money to reconcile your books at the end of the year, right? You have to make sure that the transactions or essentially the people you did business with have the exact same numbers as you. So let's say you buy 1,000 trucks from a company for let's say 20,000 a piece, but then that company that you bought it from, they try and claim that you only paid them 18,000 a piece at the end of the year. Now you have this discrepancy between these two systems, and you have to go back through all the books, and you have to go look through all the checks that were written, and it's a complete pain. But if you just have both of these companies share a network, a blockchain network, that just says, these are all the transactions that happened, it's completely auditable, and you don't have to go send someone in to do like 100 man hours of investigation. It's just all right there. So that's a really great use case. Asset registries are a really great use case, because essentially, when you store assets, you'd want them to be in a place that's really hard to change and unhackable. And if you program blockchains right, and you program your smart contracts right, these things will be unhackable. And so that's a really great use case, right? Because let's say you have a ton of gold. You say, hey, let me register this gold that I have in the physical world on the chain, and people can buy this gold and trade it as a kind of financial commodity, even though they don't, actually have to, have the whole bars in their hand. Supply chain management obviously is another really big use case, because you can see, okay, hey, this item I bought went from point A to point B to point C, and so as long as I trust that it was actually from point A, then I can see the whole chain of where this thing came from. For financial services, peer-to-peer transfers, loyalty points, and kind of remittances are the big use cases. So with cryptocurrencies which rely on blockchains, sending money is super easy, and kind of going from one currency to another is very easy as well. And kind of for value exchange, you have kind of smart contracts, which are great for kind of embedding logic on a chain, and you could also kind of integrate somehow with kind of digital content delivery. So you'd have a smart contract, but the smart contract would really be only the back end, and you'd have kind of traditional web powering the front end and all these other things. So let's also just kind of go through this course that we have coming up on the 23rd. It's a 14-week intensive boot camp, and it's designed to take you from like knowing nothing about blockchains to really understanding how they work and how to program decentralized applications. And kind of not only is it just like, programming decentralized applications, you really understand the system you're building on, which is really important when you're building applications that are mission critical. We kind of cover all the key building blocks for Ethereum. We go over the standards. It's very project focused. So we kind of don't just say, okay, here's a lecture. We say, okay, this is a lecture. Now go and build this, because that's essentially what jobs need. They need people who can go design and build decentralized applications. We also have a very large emphasis on security and rigor. So when you're programming smart contracts, the code you deploy is essentially final. And when you deploy code that can never be redeployed, if there's a security hole in your code, like so much money can be lost. For example, the Dow hack, these guys figured out how to go exploit this little thing in this contract, and they were able to make off with like $30 million. So we really emphasize how you can design your contracts in a way that people can't get in and steal any money or steal anything they're not supposed to be taking. We also have a residency program to help students get jobs afterwards. So we don't just like take you through the course and teach you all this stuff and say, okay, goodbye. We take you through the course and then we say, okay, let's help you get a job, because that's essentially what the Den is built for. We want to accelerate the decentralized future and create engineers that can go out and deliver quality code in a production environment, and go and land these kind of high-paying blockchain engineering jobs that there are right now. We also have strategic partnerships with blockchain hiring companies in order to place our students into jobs afterwards. We also have a coding gym And after you come to the course, we'll let you come to the coding gym for free and essentially do interview preparation. Yeah, and this is just, for the kind of the whiteboarding sessions, we teach you how, the behavioral and the coding aspect of whiteboarding, so you can just kind of get through interviews very easily. We also have a blockchain for business course. It's a 2-day boot camp. It kind of talks about what business leaders need for blockchain, and the things that project managers need to learn about. And then the second day, it's kind of a workshop where you design thinking techniques and you figure out how you can put blockchain in your current business and not just use it as a buzzword like, oh, blockchain, blockchain, blockchain. No, we say, okay, no, here's a way where you can actually integrate blockchain into your business in a way that would make sense and add value, and not just do it to kind of be part of a trend. And after you kind of come through our program, we'll connect you with our network of developers who are looking to build out portfolio projects. And that way, our students, they get to build a project and show to employers, and the business people get to build out a POC at a very, very low cost. So thank you guys for all coming out today. Next in the series, we'll have Ethereum 102, where we'll actually be going more into smart contracts. And I want to give out this code to just say thank you to everyone for coming out. The code is ERC721, and it's only valid for this weekend. It's lets you get $200 off the developer courses, and $75 off of the course for business professionals. So you can save some money on our courses with that. And if you think you're a really talented and smart coder, and you want to learn blockchain, we are offering a scholarship for select students that apply. So if you go to our website, theden.io /apply, or /, I always get those mixed up, you'll be able to apply to get a scholarship, and then we can kind of see whether or not you qualify. So if you're in the top, coding talent, we'd love to have you come by and apply for a scholarship. Other than that, we have Telegram, we have Twitter. You can follow us there. And I think that's it for all the presentations, but I would be welcome to take any questions you guys have. Yeah.
Great. We have no questions right now, but if something comes up, guys, feel free. I think you covered everything really well, so no open questions.
All righty. I do believe we have a lecture series coming up this week. So if you go to DenNexus, DenNexus.eventbrite.com, you can see all our future and upcoming events. I think we have we have a few events coming up this week, some very interesting speakers, free pizza, and you get to kind of meet a lot of people in the blockchain space. So I would say, if you're into blockchain, definitely come by these events. They're completely free. They're just a good way to get out in the community and meet people.
Right, yeah. And you're much closer to ask questions for.
Yes.
Yeah.
Yes.
Great. I think that's it then. Thank you again from Guru, he said. So thank you for getting a lot of good insight. Cool.
No problem, Guru. Glad to have you.
Great.
Alrighty. I think we'll sign off now. Thank you guys for coming out.
Thank you.
To an Ethereum 101 class here, and next time we'll get a little bit more technical. All right. Bye-bye.
Bye.